This is the problem 2, regular expression to DFA. Here, the problem is totally different, so I wanted to solve this. So let us take the regular expression. This is the regular expression. Now, what is the first step? You all know that you have to augment it. Okay, that is the first step. Second step, you have to number it. Okay. Third step, you have to construct the syntax tree, reading the input from left to right. While you are constructing the syntax tree, you should be careful that star node has only one children and concatenated node will always have two children. Similarly, OR node will also have two children. Here we don't have OR, so we will concentrate on star and concatenation. So this is nothing but a concatenation operator between the terminals that is given on your irregular expression. Let us start constructing the tree first. So first A, then we have B. So this 2 is concatenated. So it becomes a concatenation. Okay. Then it is concatenated with A. Then it is concatenated with B. Then it is concatenated with hash. I hope many of you have drawn it correctly. Seeing my previous video, you have understood how to draw it. So as you go by, if you keep drawing, you will be an expert in finding the proper syntax tree. Because the syntax tree is the first step and it should be properly drawn, otherwise your whole sum will go wrong. So make sure that you draw the proper syntax tree by following the rule. Now second, I have told you after construction of the syntax tree, you have to find the first question and the last question. For the first question and the last question, if it is a leaf node and the leaf node is not an empty, then their questions becomes their first question and the last question. For A, it is the one is the first question and one is the last question. Similarly, for B, 2 is the first question and 2 is the last question. For this A and for this. Okay. Now we have done with the leaf nodes. Now we move on to the next level, that is your root node. So when there is a star node, for the first question I have told you it has only one children. Whatever the first question will become the star node first question, and whatever the last question of the child node, that becomes the last question of the star node also. So here also same. Okay. Now comes to the cat node. When it comes to the cat node, if C1 is nullable, then 1, 2. Okay. Union of first question of C1, union of first question of C2. That will be the first question of the cat node. That becomes 1, 2. Okay. Now C2 is nullable. Yes, in our case C2 is also nullable. Then what you have to do? The union of the last question of C1 with the last question of C2. Again, this is also becoming 1, 2. Okay, now we move on to the next node. This is the next node, and here you have two children, one C1 and C2. This entire thing can go nullable, right? So what happened? You have to do the union. So C1 could be nullable, so you have to do the first question union. It becomes 1, 2, 3, and our last question is the same. Okay, so here it is not nullable. So 1, 2, 3, and what is the last question? It's 4. Similarly, 1, 2, 3. What is the last question? It's 5. So that's all we have. Find the first question and last question. Okay, now let us see the follow question. So follow question is calculated only for the star node and the dart node. For star node, that is simple. It's a recursive one. So what happened? Always the last question is followed by its first question for star node. For us dart node, we have two children, C1 and C2. Always C1's last question is followed by C2 first question. Okay, so C2 first, it's followed by C2 first question. This you have to have in mind while you are doing the follow question. Now let us go to the sum. First step is to write the states. 1, 2, 3, 4, 5 states we have. And then also the input symbols. Okay, write the input symbols. We have A, B, and hash. Okay, so now we will start with the star node. So I already told you, according to the star node rule, this 1 is always followed by the first question of 1. So write it 1. Okay, similarly for this star node, last question is always followed by the root's first question. For 2, it's 2. Okay, now we go to the dart node. Okay, dart node has two children, that is C1 and C2. So always last question of C1 is followed by the first question of C2. For 1, you will have 2. Okay. 1 followed by 2. So, I have written. Okay. Now, similarly, for the next node, we have done this node. So, we are moving for the next node. So, this node has also have 2 children, C1 and C2. What is the last position of C1? 1, comma 2. So, what it is following? It has to be followed according to this rule. It has to be followed by the C2's first position 3. So, 1 and 2, write 3. Okay, done. This node is over. Now go to this node. Okay, so it has 2 children. This is C1 and this is C2. Always the last position of C1 is followed by the first position of C2. For 3, it is 4. Similarly, for 4, it is 5, and for 5, it is 6. Now you can also cross verify it. I told you on the method. So you can see that A can be followed by any number of A. So 1 position. A can be followed by A. So 1 position. Okay, A can also be followed by B. So 2. So second is there. So if it goes none, it can be followed by 3. So you have 3. Similarly for B, it can be followed by B itself. So 2. So it can also be followed by A. So 3. Okay. So its logic is correct. Your follow question is correct. You can check like this. So similarly for 3, the follow question should be 4 only. So we have written 4. Similarly for 4, it's 5 only. Okay. So last is the end. That's it. So this is how we do the follow question. You can also cross verify whether you have done correct. Okay, now we are going to draw the DFA diagram. You all know that we have to start with the root of the tree. So root of the tree is 1, 2, 3. That will be your start state 1, 2, 3. Same rule I have told. For each state you have to give the input A and B and check what is the state transition. Okay, now for input A on state 1, you can see follow question is 1, 2, 3. Okay, this is your state. For 2, we don't have, so it's an empty string. Okay, for 3, we are having the state transition on the follow question 4. So, 4. So your new state is 1, 2, 3, 4. Okay, so write it 1, 2, 3, 4. So that is your new question. For B, you know that it is going to be a state called 2, 3. Okay, for on input B, because on here and here we don't have input for B. Only on state 2 we are going to have on input B. So it is going to be new state 2, 3 on input B. So on A it is going to 1, 2, 3, 4. On B it is going to 2, 3. Okay, from the first question. Now we move on to the second state 2, 3. In 2, 3 you know that on 2 we don't have a state transition for A. But for 3 we have a state transition for A, that is 4. Okay, so you can see that for 2 we don't empty state union. Okay, on 3 we have for A we have a state transition as 4. Okay, so when you do the union you will get 4. So the new state is 4 now. So on input A it is going to be a state called 4. Okay, now on input B it is going to stay on the same state because 2, 3 is a okay. Now coming to this on the input transition of 1, 2, 3, 4, if you give input A, what happens? Same state. Okay, same state on A. On B, if you give, you have a new state that is 5. We are moving to a new state 5 on B. So 2, 3, 5. So on B, 2, 3, 5. Similarly, for this state 2, 3, 5 on input A, it is going to on 3 on 4 it is going to 4 state. So on A it is going there. On B it is going to stay in the same state. Similarly for 4 on A, no, 4 on B it is going to a state called 5.